Alright, welcome to Unit 5, Lesson 2. This is the start of graphing linear equations. Okay, let's go ahead and get started. Okay, this example says, use the graph to decide whether the point lies on the graph of x plus 3y equals 6. Justify your answer algebraically. Okay, so what they want us to do is, this is the graph, okay, for this line right here. X plus 3y equals 6. And we want to know, does the point 1, 2 lie on the line or not, and does the point negative 3, 3 lie on the line? And this is important. It says justify your answer algebraically, because sometimes, just by looking at a graph, it can be a little inaccurate. Okay, so it may look like it's actually crossing somewhere where it's not. Well, the first thing that I'd want to do is go ahead and rewrite my equation here. Okay, so I'm going to do that. X plus 3y equals 6. And we want to know, does the point 1, 2 actually fall on the line? Well, if you look here, okay, the point 1, 2 is right here. Okay, and it looks like the line is a little bit off of that. Okay, so it looks like it doesn't exactly fall on there. So we want to make sure, though, and check it algebraically. Well, remember when we write ordered pairs that x comes first and y comes second. So what I'm going to do with these numbers is I'm going to plug 1 in for x into my equation and plug 2 in for y, and then see if it checks. Okay, so I'm going to go ahead and plug in 1 for x plus 3y means 3 times y, so that's 3 times 2. And I want to know, does 1 plus 3 times 2 equal 6? Well, that's 1 plus 6, and 7 does not equal 6. Okay, so there's my work algebraically. That shows me that for sure the point 1, 2 does not lie on this line. Alright, now we're looking at the point negative 3, 3. That looks like it's right here, right about on the line. But again, to be sure, we need to check this algebraically. So I already wrote my equation up here, so now I'm just going to go ahead and plug in the numbers. So for x, I'm putting in negative 3 plus 3 times my y is 3. Now I know, does that equal 6 or not? Well, negative 3 plus 9, and negative 3 plus 9 is 6. So 6 does equal 6. Okay? So for B, the answer is yes. And for A, the answer is no. Okay? So A, no, that point does not lie on the line. And for B, yes, it does. And there's my work to show for it. Make sure you show your work. Don't just do this in your head. Alright, let's go on to another example. Okay, this example says to find 3 different ordered pairs that are solutions of the equation. Okay? So all we need to do is pick some values for x to plug in and see what we get for y. That's all they really want us to do here. Now the values that we're always going to tell you to plug in for x when you do your table of values for graphing are negative 2, negative 1, 0, 1, and 2. So there's 5 of them. This one only asks for 3. So what I'm going to do is I'm going to rewrite my equation first. Okay, and I need to find 3 different pairs. I'm going to use the numbers negative 1, 0, and 1 for x's. Okay, and I'm going to see what values of y I get out of that. Well, what I'm going to want you to do is to actually make a table of values for this. Okay, so we're going to have x's. There's our function. And we're going to have y's, and then we're adding in a new column to these now for when we graph. And this 4th column over here is where you will write the coordinate. Okay, that's the ordered pair. So again, normally for x we're going to plug in negative 2, negative 1, 0, and 1, but this one only asks for 3 values. So I'm going to plug in negative 1, 0, and 1, and see what I get for y. Okay, so I've got y equals 3 times negative 1, and this is plus negative 5 when we change it to adding. Here I've got y equals 3 times 0 plus negative 5, and here I've got y equals 3 times 1 plus negative 5. Okay, well up here, 3 times negative 1 that is negative 3, plus negative 5, that gives me a y of negative 8. So over here I'm going to put my ordered pair. My ordered pair, my x value was negative 1, and the y that I got was negative 8. So that's one ordered pair that's a solution. Okay, that tells us that that's a point that would be on the line of this graph, if we were to actually graph it out and draw it. Okay, the second one, 3 times 0 is 0, plus negative 5, that is negative 5. So my second ordered pair, my x is 0, and my y is negative 5. And for the last one, 3 times 1 is 3, plus negative 5, and 3 plus negative 5 is negative 2. So now my last ordered pair is 1 and negative 2. Alright, and this over here is my answer to this problem, okay? Because I asked for 3 ordered pairs that are solutions. So there's my 3 ordered pairs. Okay, I always want you to use, if it asks for 3 different ordered pairs, use these values right here, negative 1, 0, and 1 to start with. Okay, but make yourself a table of values like this so you get used to it, because we're going to require you to make these every time you graph a line. So all throughout this unit. Alright, let's keep moving on. Okay, all linear equations in x and y, that means where I have an x variable and a y variable, can be written in this form. ax plus by equals c. Okay, where a, b, and c are constant, so they're just numbers. And then this is called standard form. So here's a bunch of examples right here. This is standard form. 2x plus 3y equals 4. So my constants, my a is 2, my b is 3, and my c is 4. Okay, then here we've got negative 5x minus y equals 7. Well, this is why we change things to adding all the time. So if I look at this one here, I would change this to negative 5x plus negative y equals 7. So now I know my a is negative 5, my b is negative 1, and my c is 7. Okay, here in this one, negative x plus y equals 3/4. My a is negative 1, my b is positive 1, and my c is 3/4. And the last one, again, standard form here, my a is 1/2, my b is 3/4, and my c is 12. Okay, again, this is just called standard form when you have x and y on the same side. Alright? Okay, let's go on to another example. Last one. Okay, now function form of an equation means y equals form. That means we want to rewrite the equation so that y is a function of x. And we've done this before in the last unit. Okay? Or in easier terms, what this means is we want to get y on a side by itself. Okay? So function form is y on one side and x on the other of the equal sign. And in function form, x is the domain or the input, and y is the range or the output. And we've talked about that before, what those mean. Okay, the input, the x is what goes into the equation, the y is what you get when you solve it, okay, what comes out of the equation. Well, this equation right here we want to rewrite in function form. And what form is this in? Okay, we just talked about that. It is in standard form right now. Standard form is not, a lot of times it's not as easy to work with for graphing. We're going to learn some things about function form or y equals form that make graphs really easy to work with, and you don't really have to use a table of values for them. So it's a lot of times beneficial to get standard form into function form. Well, we've done this before. Our goal, first thing I'm going to do is rewrite the problem. Okay, make it a little bigger here. And our goal is to get my y's all by itself. Okay? Eventually I want to get one y by itself, but for now I've got to get 3 y's by itself first. So to do that, I'm going to take away x from both sides. Okay? X minus x, that cancels, leaves me with just 3 y's over here. And 6 minus x, I can't do anything with that. I just have to write it like this, because they're not like terms. I can't combine them. Alright? Well, then, the next thing I need to do is I need to get y by itself. So to do that, I'm going to divide each side by 3. And I need to divide this whole side by 3. That's where some of us struggled in the last unit. Okay, we had to divide the whole side by 3. So these cancel, and I get y equals 6 minus x all over 3. Okay? Now before, we've said that we can't simplify this really because 3 goes into 6, but it doesn't go into 1. Alright? But now, it's going to benefit you sometimes to go ahead and simplify this, and here's how you can do this. Okay, and a lot of you don't like fractions, but it'll benefit you to be able to do this. So, I'm going to start by putting y, and then here, I can simplify these, because 6 divided by 3 is 2, minus, and then here, there's really a 1 that goes in front of here. Okay, so 1 divided by 3 is just 1/3 x. So I could simplify this, okay, if I wanted to. Either one of these is correct, okay? This one's probably the better one to get used to, because you'll see this a lot. And again, these are called function form. Okay, so either one of these is an acceptable final answer. But again, preferably get used to doing these ones. Alright, that's the first part of this lesson for graphing. Okay, so no actual graphing yet, but we'll get to that the next lesson. So for now, good luck on your homework.